So in the last video, on the last lecture, we have seen how to convert two square waves or two square pulses of dissimilar width. So today we will try to see how to convolve a square signal with a triangular signal. And this is your x1t and this is your x2t. So as I told you in your last class that we can call it that we are convolving two signals x1 and x2 and we are evaluating it at some time t. So we can use either of these two definitions, these two formulas, x1 tau, x2 t minus tau, or x2 tau into x1 t minus tau d tau. Why I am going to use this formula rather than this formula, and the justification for this is that since we have to shift first in order to evaluate or in order to get this term, second term, we have to first take the mirror image of this signal with respect to y-axis and then we have to shift it, and the shifting would depend on the value of observation time t. So by just observing these two signals, you can say that the taking mirror image of this signal and then shifting this will be easier as compared to this signal. So we will use this second definition in order to evaluate the x1, the convolution of x1 and x2. So as I told you in your last class that we have to first, in order to get the second term, we have to follow these two steps. Which is nothing but x1 minus tau. Correct? These two are equivalent terms. So this is nothing but taking the mirror image of your x1 signal with respect to y-axis, and this is nothing but shifting of your x1 signal with value t. So this is your x1 signal. We take its mirror image, so it will not make any difference since it is already symmetric about y-axis. So you will get the same signal. This is your x1 minus tau. And then you will shift it by amount t. So if you shift it by amount t, you will get such a signal. Now, since we have got the second term, we have to multiply the second term with the first term and then integrate it. So, our first term is, just pardon me if this is not it should be a bit larger, but it's okay. And the height is 1, so this is your x2 signal. So you have to first make cases like we did for the first example, and accordingly we will multiply these two signals. By cases I mean you have to find out the values or the ranges of t, various ranges of t, and then you have to evaluate these integrals. So the case 1, we choose a case 1 like this, that your r plus t is less than 0, for example. What do I mean by that? It means that this edge of, because you can do either, you can also shift it in this direction, right? When your time is negative. So in that case, how would this signal look like? This signal. If you draw this signal, it means when your t is less than or equal to minus r. So in this case, your x1 t minus tau would look like this. See, when we say we are right shifting this signal, under the condition that your t is positive, right? Correct. But as you can see that when we plot our signal, it can also take negative values, right? So when your t is less than equal to minus r, the reason the overall, since we multiply these signals, and when we multiply these signals, we have to take the limits of integration in such a way that both of the signals are non-zero, right? So if you see, there is no common region or common line where these two signals are non-zero. So for this, the value of integral will be 0. So convolution for this case, convolution of these two signals for this case will be 0. Next, your case 2 is when your time interval, your time is greater than minus r. So now you are shifting your signal like this, a bit towards right. So this end of your signal will be r plus t. This is your minus r plus t. And your value of t is such a way that your r plus t is greater than 0 and your minus r plus t is less than 0. And one more point, your r plus t is less than the 3r. Your r plus t is less than 3. So if you just take the intersection of these three, you will find that t should be greater than r and t should be less than 2r. So this is the second case. This is the second case. Let me see once more that your r plus t is less than equal to 0. This is possible when t is less than equal to minus r. So I hope this is okay. And when your t is greater than minus r, when your t is greater than minus r plus t less than t is less than equal to minus r, and when your t is greater than minus r, and your t is less than r. So if you take the, I will, this is my mistake, I should write. Because once you solve all the three conditions, you will see this intersection or these three is minus r to r. So you will get your second term x2 as this. And then your aim is to multiply this signal, the second term with the first term. I forgot to mention the height for these two cases, and the height of both of these signals is 1. This is x1. No, this is x2 and this is x1. So this is x1, I beg your pardon, and this is your x2. So if you multiply these two signals and then you integrate it, right? Because we have second term, we have to multiply it with the first term and then integrate. So if you just try to find out the common region where both of these signals are non-zero is from 0 to r plus t, that will decide your limits of integration. And if you can see if you multiply these two signals for this x1 is 1 and x2 is 1 by 3r into tau, because you take the equation of this line and you integrate this, you will get 1 upon 3r tau square by 2 between 0 to r plus t, 1 upon 3r r plus t whole square divided by 2, 1 upon 6r r plus t whole square. So for this case, when this edge of yours second signal, this edge of your signal, this square signal or square pulse is positive or in the right hand side of the y-axis, and this edge of your square pulse at the left hand side of this y-axis. So for this case, the integral for, and this case is possible if we have seen mathematically that this case is possible when all of these conditions are true, and this is true when your t is between minus r to r, and this will decide your. So when this case is true, we multiply both of the signal and we see that both of these pulses are non-zero between 0 to r plus t. That will decide the limit of integration. We multiply these signals and we evaluate the integral. Next, what see, we have to see the other case, and these cases we see by visualization, by shifting. And now you shift your signal further. This is your signal which will be fixed. Now you are shifting your other signal in such a way that the first edge, the right edge of this square pulse come here, and the left, this edge is inside this, right? This case we have already considered here, so let us just shift it like this. This is your case 3. When you see that minus r plus t and r plus t, so minus r plus t is greater than or equal to 0. So with this case we are also involving here, including here, because I have written the equal to sign, right? So in the same figure only we are plotting both the signal, and then intersection or and r plus t is less than 3. So if you just try to find out the condition on t which will satisfy both of these, is t should be greater than r but should be less than 2r. Yeah, so t should be greater than or equal to r but less than 2r. Under this condition, if you try to find out the common reason where both of this signal is non-zero, is this minus r plus 2t r plus t. So this will decide your limits of integration, and as you know the height of both is 1, and for this reason this is 1, your x, this signal is 1 for this region, and this signal you have to write the equation of line which is this, and once you solve it you will get minus r plus t to r plus t 1 upon 6r r plus t whole square minus r plus t whole square. A square minus b square is a minus b, a plus b, so that you will use here, and 1 upon 6r r plus t minus r plus t, a plus b we have used, and now a minus b. So you will see 1 upon 6r 2t multiplied with 2r, it will r will go away, 3, so you will get 1 upon 3 2 by 3 into t. Next you have to again visualize geometrically that you are now further shifting this square pulse in such a way that this edge comes out of this edge of triangle wave, but this edge is inside the edge of this green edge, right? So let's see that case. This is your up to here. Now you are shifting your square pulse in such a way that minus r plus t end is inside 3r and r plus t end is outside. We are having both x1 and x2, right, in the same plot. So we'll see this case is possible when your minus r plus t is less than 3r and r plus t is greater than 3r. So if you see, this is possible when t is greater than or equal to 2r and minus r plus t is less than or equal to 3r and r plus t is greater than 3r. When your t is greater than 2r but less than 4. So this case 4 is when your shifting is such that it is between 2r to 4r, then such a scenario will be true, and the limit of integration will be you have to find the region where both of these are non-zero. So this is the line where both of them are non-zero. So you can write minus r plus t to 3r, and since this is the same, you can do, because in this region or in this domain x1 is 1 and x2 is this line, right? So if you integrate it again, you will find this, and I leave this to you to solve this. And the last scenario will be your case 5 will be you have now shifted your square pulse such a way that minus r plus t comes out of the. Now you have shifted your square wave such a way that it comes outside the. So this is 3r and this is your minus r plus t and this is your r plus t. So minus r plus t is now greater than or equal to 3r, which is only possible. So when your t is greater than 4r, you will not find any common line or common domain where both x1 and x2 are non-zero, so integral will be 0. Correct? So now you can solve this problem. What we have done, we have first taken these two pulses. We now want to evaluate the convolution of x1, x2, and we want to evaluate at t. And I told you that this factor or the time at which we are want to observe the value of our convolved signal will decide the shifting of the signal, right? And it will depend which of these pulses we are using for shifting, right? So I told you that we will use this formula, second formula, and which will automatically make this signal to be fixed and this signal to be, this will be fixed and this will be varied, and the shifting or the variation or the shifting will depend on the value of t. So just try to solve this problem. Once you understand this problem, this convolution, try to solve this. What is the convolution of this signal? This is your x1 signal and this is your s2 signal. Height of both is 1. Try to solve this signal. Right? Try to solve the convolution of these two signals. Thank you.